Alright guys, so today we're going to cover latitude and longitude. I think you guys did a lot of latitude and longitude work last year, so this will be a review for a lot of you guys. So we'll start with latitude. Latitudes are sometimes called parallels because the way that the lines run across the globe, they're parallel lines. Hopefully you learned in math that a pair of parallel lines will never intersect or never touch one another. So when we measure lines of latitude, we start at the equator. So you start at 0 degrees here at the equator, and you're either going to go north or south. So that's measured from 0 degrees all the way up to 90 degrees, which again, if you've hopefully learned this in math, you've got that 90-degree angle, it's a right angle. So it's going to go from 0 all the way up to 90, either north or south, based on which pole you're getting closer to. Now, as far as helping you try to remember which way those lines run, there's a couple different thoughts or theories. I've had students before tell me they think about it like the AT&T symbol, how it always has the latitude lines going across the sphere. When I was your guys' age, I always remembered it as a ladder. It's like the steps or the rungs of a ladder. So ladder, latitude, it kind of worked out the same that way. Now for longitude lines, they're going to run the opposite direction of your latitudes. So with longitude, they're measured from 0 all the way up to 180 degrees, either east or west, based on which side of the prime meridian they are on. So your prime meridian is going to be 0, and then if it's to the eastern side, shocking I know, it's going to be east, western side will be west. As far as how those lines run, or help you to remember, all of those lines of longitude are the same length. Okay, so they're sometimes longer than latitude lines are. If you need another visual to try to help you remember, what those lines look like or which way they run across the globe, think about it like the grooves of a pumpkin. Grooves of a pumpkin, they run from stem to the bottom, just like a longitude line would. So we use latitude and longitude to find absolute locations anywhere on the globe. Latitude is always going to be listed first, then longitude. So if we're going to use our map here and try to pick out a couple places, so it looks like our first example down here is 20 degrees north, 20 degrees east. So our latitude's listed first, then our longitude. So I always tell people start at the equator. That's at 0. And it's telling me 20 degrees north, so I know I need to go towards the North Pole. So I come on up to 20 degrees north. I know whatever point or area that's asking me to find is going to be on this line somewhere. So to narrow it down, I need to look at my longitude then. It's 20 degrees east. So I start at 0 here at the prime meridian. I know the east is this direction. There's 20 degrees. Bring it down to where it intersects the other 20 degrees line, I would end up right there in Africa. Okay, so let's try this with using a different map. So I'll give you guys a copy of this one here, and we'll work with these examples up here at the top. So first one that we can see here on the actual screen, you guys have another example on the top of your map. Let's go ahead and do this one here with 20 degrees south, 160 degrees west. So we'll start here at the equator. So right here at 0, and we know we're going south. Okay, we're going towards the South Pole. So here's our 20 degrees south. So we know our point's got to be somewhere along this line. Okay. So, and that's my longitude line. Okay, that was my 20 degrees south. My next is 160 degrees west. So again, we're going to start here at 0. We're going to start here at our prime meridian. And we've got our compass rose up here that tells me the direction. So I know anything on this side is going to be east. That is the worst E ever drawn. And this is going to be west. Okay, so that's going to help us know which side we need to head toward. Now, with our, that's better. So we need to go to the west direction. So scroll over here and we find 160 right there. Now, with this map, you're going to notice that your longitude lines do have a curve. They do follow a little bit of the curve of the globe. So with our 160, we need to follow that curve, bring it all the way down to where it crosses, and that tells us that we are at point S. Okay, so we'll just put a S up here at the top, and that shows where we were. Okay, so you've got 8 total up there. Go ahead and do those 8 on your own, and then we'll check them together here once you're all finished. Alright, so now that you've had some time to do the rest of those on your own, let's go ahead and check them real quick. So our next one here was 40 south, start at 0, come to 40 south, and 100 west, start at 0, west, there's 100, tells us that one's going to be H. We have 60 north over here. 60 and 100 west. So we already had 100 west marked from before. That's going to be Q. We have 20 degrees north over here. There's our 20. I know it's kind of cut off here on the screen for you guys, but there's 20. Our point's going to be here on the line. And then we have 160 east. So on this side now, 160, follow the line, that'll be O. 60 south, start at 0 here with our equator. We know the direction is going to be south, so we go toward the South Pole. We find our 6 degrees south, run our line across, and 180 degrees east. So you're going to see in your map there's 2 180s. In reality, that's the same line, but for our map here, we're going to do them separately. So, 180 degrees east, we're going to come all the way over here on east. There's our 180, and it's this far line all the way over here. We run that down the page, that'll take us to W. And then last, we have 10 degrees north, 20 degrees east. So this one tricks people sometimes, because if you look on your page here, you're going to see where there's not a 10 degrees north anywhere. But we have 0 and we have 20, so we know 10 is going to be in between them somewhere, so it's going to be right in here. So we're going to go ahead and draw that line across there. Then we've got 20 degrees east, so again we start at 0 with our prime meridian. We know that east is this direction. Follow it down. And we end up here at point D. So we'll use this map a little bit more for some practice on another sheet that we'll do here in a second. But we'll finish our video today with a little video.
Do you have any more of those energy bars? Energy bars. I think the cold has frozen your circuits. Let's answer a letter. Dear Tim and Moby, I live in California. Where can I go to see latitude and longitude lines in my state? From Dale. You can't actually see latitude and longitude lines in real life. They're imaginary. We use them on maps and globes. They crisscross to form a grid over the Earth. And you can use this grid to pinpoint locations anywhere on the planet. Longitude lines run north-south. There are 360 of these imaginary lines, each of which is called a degree. You can remember which way they run because they're long for longitude. The 0-degree line, or prime meridian, runs through Greenwich, England. There was an observatory at Greenwich where British astronomers had been studying longitude. The rest of the world relied on their findings, so when it came time to name a prime meridian, scientists around the world agreed on Greenwich. There are 180-degree lines to the east and west of the prime meridian. If you are 77-degree lines to the west of the prime meridian, your longitudinal location would be 77 degrees west. Latitude lines run east-west. You can remember which way they run by thinking of them as rungs on a ladder. Latitude, ladder. 0 degrees latitude runs along the equator. There are 90-degree lines to the north and south of the equator. 90 degrees north is the North Pole, and 90 degrees south is the South Pole. Hey, let's map something. If you are located at 38 degrees north of the equator and 77 degrees west of the prime meridian, you are said to be at 38 degrees north, 77 degrees west. You write that like this. By the way, that's just about the location of Washington, D.C., but not exactly. Because the Earth is so big, there are a lot of miles between each degree of latitude and longitude. For more precise measurements, we use minutes and seconds. There are 60-minute lines between each degree of latitude and longitude. The precise coordinates for Washington, D.C. are 38 degrees, 53 minutes north, and 77 degrees, 2 minutes west. To get even more precise, there are 60-second lines for each minute line. Coordinates of 38 degrees, 53 minutes, 22 seconds north, and 77 degrees, 2 minutes, and 41 seconds west would be written like this. You could also just measure fractions of minutes with decimals instead of seconds, like this. And there you have it, latitude and longitude. You know, now that I think about it, even though you can't see them, you can use a GPS tracking device to figure out your coordinates. GPS stands for Global Positioning System. So, let's see, we're at 60 degrees, 5 minutes, 22 seconds north, 159 degrees, 13 minutes, 10 seconds west. Hey, did you find those energy bars yet? That's closer.